Alright, let's look at the homework 3.6, problem number 3. Alright, the boat is being pulled toward the dock as shown in the figure on the right, so we have a picture there. And rope is being pulled at the rate of 1 foot per second. Alright, so maybe we should start the writing stuff for, maybe I'll just underline it. So here's some rate is given. Alright, pulled in at the rate of 1 foot per second. And how fast is the distance between the dock and the boat decreasing when it is 4 feet from the dock? Alright, so here's some numbers given. Alright, so there are some changing quantities, so we're going to give some variables. So I'm going to give, let's see, the distance between the boat and the dock. So I'm gonna call this guy, give this guy x, right? Because it's a horizontal distance. And also the length of the rope is changing. So I'm gonna give, say, maybe I'm gonna call it r since it's a rope. All right. Then try to identify what's given. All right. So the number given. So let's see, at the rate of 1 foot per second. So the rope is pulled in at that rate, so the length of the rope is decreasing at that rate. So we know that this is given. Rate of change of the length of the rope with respect to time is going to be, so this is decreasing, so it's a -1 foot per second. All right, so that's given. And also when at this point the distance between the boat and the dock is 4 feet, so x is equal to 4. All right, and then we want to find r. Actually, we can find r. So r is just using the Pythagorean theorem. All right, so at this point x is equal to 4. Right, and the height here is 4, so square root of 4 squared plus 4 squared, so square root of 32, it's actually 4 square root of 2. So by Pythagorean theorem, r is 4 times square root of 2, right? Because it's a 4 square root of 2. All right, so those are given. And the Pythagorean theorem gives us this. We know that the x squared and plus 4 squared equals r squared. Alright, so those are the given, and we came up with an equation using a Pythagorean theorem. And the question is this, so we're looking for how fast is the distance between the dock and the boat decreasing? All right, so we're actually looking for dx over dt. All right, so this is the guy we're trying to find. All right, so let's find that. So in order to get to that, we have to take the derivative of this equation. So let's take the derivative with respect to t. All right. Derivative of x squared would be 2x times dx over dt. And the derivative of 4 squared would be 0 because 4 squared is just a number. And this is equal to, right, derivative of r squared would be 2r, then multiply by dr over dt. Alright. So since what you're looking for is dx over dt, so I'm going to just try to isolate that by dividing it through by 2x. So we get dx over dt is equal to, we have 2r dr over dt, which is already on the right. And then we divide by 2x, right? So we can cancel 2 on top and 2 on the bottom. So we get r over x dr over dt. Right? But we actually have all these guys already figured out. Right? R is, from the Pythagorean theorem, we figure that it's a 4 square root of 2, and divide by x. X is 4 at that point, and dr over dt is -1. Alright, so we can cancel 4 and 4, so we get, this is actually simply just negative square root of 2. Right? And let's see if you remember square root of 2. So what is square root of 2? Alright, so I'm going to just find the square root of 2. Square root of 2 on GeoGebra. And we need, let's see, I think we need a little bit of 3 decimal places, I think. So we have, let's see, option, rounding 3 decimal places. Alright, so it's a 1.414. Alright, so let's type that in. Right, so distance between the dock and boat is decreasing by 1.414 feet per second when the boat is 4 feet from the dock. Alright, so let's check the answer. Alright, got that. Alright, that's it. I hope that this was clear.